Hello and welcome to my channel. In this part, so far we've been creating functions, and these functions has been is the board empty, find legal move, initialize the board, and they've been separate. They've just been doing one task. For example, we wanted to find 4 in a row, so that's all we're doing is doing a function that's going to find 4 in a row. We haven't just said why we're doing it and why it's needed. So in these next videos, I'm going to try and explain how the game works and why we're doing these things. I'm gonna use the example of this simple game board to try to explain what I'm doing, okay? Rather than doing it on a full board. Now this is a 2x2 board. So what I'm gonna do is I'm going to make an example game. So if I'm here, I'm gonna have 2 choices. I'm gonna be able to move here or here, which is represented by 1 or 2. Now, whichever one I do, it doesn't make a difference because the moves are going to transpose. So what I'm going to do is, I'm going to move one sec. I was trying to find a shortcut way to do this, but I'm going to have to do it this way. So I move red. I'm going to ignore the 2 line because that line is going to transpose and it's going to be the same but the opposite. So it doesn't really make sense looking at it. Okay? So that's me. I've got 2 choices. I've moved 1. So this is my opponent now. How many choices has he got? He's got 2 choices as well because I've moved 1. So he's got 2 choices. He can move 1 or 2. Let's just say he moves 1 because he wants to block me and stop me from winning. Okay? So what he does is he moves, he goes here, and he moves there. So now the tree is here. And it's my move, and I've already got 1 move, which is 2. And he's only got 1 move, which is 2 as well, because obviously these are the only 2 legal moves. So the game's gonna end up looking for this particular sequence of moves. The game will look like that, and that is a draw. No one's won. Okay. So if I look at this board is complete and it can't go any further. And if I say, what is the evaluation for that board? It's a draw. So can you see this star? For that particular sequence, it's 0. The evaluation is 0, okay? Now, I'm gonna step it back a bit. I'm gonna step it back to here, and I'm gonna say here, that's me. I played 1. Now, what if at this stage my opponent played 2 instead? So I'm gonna do the lines for 2. Now, because he played 2, if I play 1, which is here, okay. So it's my turn, and I've got choices to make. I can make 1 or 2. Now, if I'm obviously I'm going to make 1, and now I've won. If I did make 2, if I played 2 instead, My opponent will only have one move, which is 1, and then it will be drawn. But I'll play 2. Now, if you notice this game terminates here because of 1. Can you see I've 1 there? So that means there it terminates. It hasn't terminated at the bottom here. It's terminated higher up because of 1. Okay. So the ones that are terminated are called leaf nodes. That's a leaf node, that's a leaf node, and that's a leaf node. This terminated because it's 1. This terminated because there's no more moves to be made. Okay? Now that same game, if I decided to go here, if I decided to go there, and then my opponent went there, no one's won. So that would be this line here. And that's got a score of 0. So this is how the Connect4 is gonna work. In this example, the board is a 2x2, so we can go all the way to the end, as in here. That is the end. And when we say ply, what we mean is it's how many moves down it is. So for example, we're here, the ply here is 1. Everything on this level is 1. Everything on this level is 2. Everything here is 3. Everything here is 4. So for example, this one terminated at level 3. This terminated at level 4. That terminated at level 4. On this game, the deepest level you can go is 4, because after 4, there's no more moves that can be made. But on our one, it's probably 10 to the power of 80 or something like that. It's 7 to the power of 42. Okay? And that's a very large number. So, next thing I'm going to show you is, I'm going to pause the video and I'm going to get something up called the min-max. Okay, I've changed the screen now. Now what I'm doing is, imagine this isn't our game, because obviously our game, if it's the person to play here, I would have 7. If it was a 7x6 board, I'll have 7, but so I've just cut it down a bit to make it more manageable. But this is just giving. I'm telling you how this is how our game will work. The computer is gonna come here, and it's gonna say how many legal moves have we got, and it would look, and it's gonna see 1, 2, and it's gonna put them in an array, and it's gonna say I've got 2 legal moves. So what it will then do, it will loop through the moves, and then it will see that this actual move will actually make the move on the board. And then this ply, what it will do is it will increment the ply. So at this stage, the ply will be 2. So it will actually make this move on the board. And then it will get to here, and then that's when the recursive function will kick in, and then it will do the same thing again. Oops, that should be 1. Then it will do the same thing again. How many legal moves are on the board? And it was going to find 1, 2, and then it's going to loop down here, and it would actually make this move. And then the ply will be equal to 2 here. And then when it gets here, it will then say, how many legal moves have we got? And then it's going to find there's 2, but in the real game, there'll be 7, okay? And then it will then go here, and then there the ply will be 3. But another thing is, I'm going to have another variable called depth. So at some stage, it's going to say we've reached the maximum depth. So when it reaches the maximum depth, what it's going to do is it's going to evaluate the position and give it a score. In our example, it's going to be either 0, minus 100, or 100. But I'm just going to demonstrate something. So I'm going to give some different. I'm just made up some numbers here, just so I can demonstrate something. Okay. So once it makes the move and it reaches the depth, it's going to give that a score, and then it's going to say what is the best score. And in this case, the best score is 4. Okay. So then what it's going to do then, it's going to look here, it's going to go here, and it's going to say the depth has been reached. So it's going to evaluate the board with this move, i.e. it will take back this move. So it's already made this move on the board, it will take it back, and then it will make this move, and then we'll say we've reached the maximum depth, what is the score? And in this case it will be 6. So it will say 6 is better than that. So it will then replace that with the 6. Okay. Now what I'm going to do is, instead of talking about that on every single move, I'm just going to run. I'm going to show you what it's going to do, but I'm not going to go into so much detail. Okay. So what I'm going to do, I'm going to take this out. I'll show you what happens. I'll show you the game theory of how it's going to happen. Now, basically, the computer is going to run through, and it's going to, all these leaf nodes is going to fill numbers here at the bottom here. That's what it's going to basically do. And there's a reason I blocked that out, and I blocked these out. I'll show you why in a bit. But that's what it's going to do. It's just going to go down to depth 4, and it's going to fill in all these numbers with whatever the valuation. In our case, it's going to be zeros and hundreds and minus hundreds. Okay. But I'm going to show you the theory of how it works. Now, in this position, yellow is a maximizer. That means yellow is always looking for the maximum move number. Red is a minimizer. That means red is always looking for the minimum number. Okay. For example, in our thing, if yellow is winning, that's plus 100. When yellow is plus 100, yellow is minus 100. If you know what I mean. But instead of doing plus and minus, what we're gonna do is we're gonna call one of them the minimizer and one of them the maximizer. Okay, so yellow is max. So here it's yellow's turn. So yellow's gonna come here first, and he's gonna put 4 there, and he's gonna say fine. Then he's gonna come here, and he's gonna say 6, and he's gonna say 6 is better than that. So he wants, yellow is the maximizer. He just wants the maximum. So what he's gonna cast away this 4, and he's gonna put 6. Okay. And then whose turn is it? It's gonna come here, and I'm just gonna put the 6 there. Now red is the minimizer. Red wants the minimum. Okay, remember that. Red is the minimizer, so red wants the minimum. Now, so that means I've got up to there. Now I've got to come down to here because I need to get that one, and to get that one, I've got to come here. So now that's the yellow who's a maximizer. So let's put the 7 in, and I'm going to show you something now, which is why I blocked this one out. Can you see that? Red is the minimizer. Red is always going to pick 6. The red is never ever going to pick that 7. Can you see that? Red is the minimizer. So red would look at these 2, and it will not pick the 7. And also, can you see that yellow is the maximizer? So yellow, he's got 7. yellow is never going to pick this one. If that was a 2, for instance, yellow wouldn't pick it. If it was a 10, he would pick it. However, if that was a 10, red is the maximizer, so he wouldn't pick it. So can you see that that is irrelevant what that is, because of the situation I've described? Okay. Now, when I program the game, I'm not going to take these. It's not going to take these into account. So what it will do, it will evaluate that. So it would actually go down this node and evaluate it. But later on, I'm going to change the algorithm so that it's not going to be min-max. We're going to be using something called alpha beta. And when we start using alpha beta, it will be a bit cleverer. So what it will do is it will cast these aside without even looking at them. Okay? Now, that's so can you see it's got 6 there. So let's just imagine that yellow is the maximizer. So yes, let's just say yellow's got to score 6 up here. So now he comes here and he wants on this side. So let's come here. Yellow is the maximizer. It's got 1 and 2. So let's say he puts 2 there, because obviously he's going to want the maximum all the time. And you got red is the minimizer. Okay, so we take that 2. Now, can you see something here? What's going on? So what we can notice here is red is the minimizer, and he's got the 2 there, and he's also got that. However, yellow is the maximizer, so yellow is going to choose the 6, and even if this is 1, even if that is a 1, it's less than 6, so he will never ever choose. So the yellow would never choose. So it doesn't matter about. So that means, in computer terms, the computer can just cast all of this off, and this may be a billion. This may be a million billion amount of positions to look at, and because of this situation where we're raised in, where that is a 2, red is a minimizer, and yellow is the maximizer. So out of the 6 and the 2, the maximizer is going to always choose the 6, and the minimizer will always choose this 2 over whatever this is. So it doesn't matter, even if that was a 100. Even let me just put 10 so we can see it. Oh, look at that, 9. Even if that was a 9, red is a minimizer, so he would always choose the 2. Now let's say if it was 1. Let's say if it was 1, 2 and 1. So let's just say he chose the 1 instead. So let's just say he chose 1. Now, yellow is the maximizer, so yellow will not choose that 1. So it doesn't matter. It doesn't matter what these are. So they can be cast aside, and you don't have to look at them. Okay. Now so in this algorithm, if it's yellow to choose, yellow would play number 6. It's a bit. An example I can give is, what if I was playing chess? I mean, what if I was playing Connect4 and I had 3 in the line, and it was my turn to play? Say if it was my turn to play here, and that's 3 in the line. That score is 3 in the line, and all I have to do is play a game, and then I'm going to win the game. And instead, I'm going to block it. I'm going to play something else. No one, you can't. If you're playing a game against someone, you can't assume that they're going to. You got to assume that they're going to make the best move, and that's what this is the equivalent of. So in this situation, even though 7 is the best move, right, it's never going to get played because the minimizer is not going to allow it to play. Okay, so how our AI is going to work? The AI is going to look at the board and it's going to get all the leaf nodes and get all the values, and then it's going to run it's going to run this algorithm. But what it is, it's going to take these in. It's not like how I've classed these off and I haven't looked at them. It is going to look at everything, so it's not going to be very efficient. And but I just want to show you that. I just want to show you two ways of doing it. Min max is not going to be efficient because it's going to consider. I was going to look at that. It's going to look at that, and it's going to look at that, and it's going to look at that, and it's not going to cast anything off. Whereas later on, in fact, much later on, after, I won't do it until I build the GUI. After I build the GUI, then I might turn it into alpha beta. So alpha beta is clever because what it will do, it will cast off things like this. You won't look at them. So it will save, for example, in the game that we play, a 6x7 move, each time you've got seven moves that you can make. So if 42 moves, 7 to the power of 42. So that's how much moves that is. So if we could cut the branches down, let's just have a look. 3 to the power of 42 equals. Can you see how much we cut the moves down to? Let's just say to a depth of 12. 7 to the power of 12 equals. So can you see? We're gonna have to look at 13 trillion moves. Can you see that? 13 billion moves. 7 to the power. However, if we could cut it down to 3 to the power of 12, we're now looking at 500,000 moves. So what that means is, instead of going to a depth of, say, 7, if we do alpha beta, we could go to a depth of, say, 12, and it will play stronger. Okay, thanks for watching the video. Until next time, bye.